Okay, so we have a question right here. It basically says that a quantity is either a scalar quantity or a vector quantity. Which row of the table is correct, right? Which row? So this is the first column is our scalar quantity column, and the second column is our vector quantity column. Now we have to guess which row has basically our scalar quantity and our vector quantity in the right positions, right? So let's first know what is a scalar quantity and what is a vector quantity, right? A scalar quantity consists of basically, sorry, not direction, sorry, magnitude, right? Only magnitude, or you could say the value, right? And vector quantity consists of both magnitude and directions, right? And directions. So basically, you need to remember these two stuff. These are more important, right? So let's check our option number A. Option number A says energy as scalar and momentum as vector. This is actually correct. Let me explain you why. Energy, basically the formula for energy, or you could say the work done, is force into displacement. These are both vector quantities, right? I will explain you in a bit why force and displacements are basically a vector quantity. For now, just assume that, not assume, just know that force and displacement are vector quantities. And when you multiply two vector quantities, they always result in scalar quantity, right? Scalar quantity, right? Remember that. Now, this thing is also known as dot product, right? Or you could say, in other words, scalar product, right? That's all you need to know. That's why when you do the multiplication of two vector quantities, it results in scalar quantity. That's why it's in a perfect position, or in a right position, right? Right position. So now let's check the momentum. Why momentum is a vector quantity, right? Momentum is a vector quantity because, let me explain you through formula, right? So the momentum formula is P is equals to mv. So P is momentum, of course, mass, this is m is mass, and v is velocity, right? So mass is basically a scalar quantity and velocity is a vector quantity, right? Vector quantity, right? So now basically, once you multiply a scalar quantity with a vector quantity, they usually or always results in vector quantity, right? Remember that. Scalar times vector results in vector quantity, and vector times vector results in scalar quantity, right? So basically, that's why it is a scalar quantity, right? So option A is basically our right option. Let's check the other options as well, which is B, C, and D. B says displacement as scalar and acceleration as vector. Acceleration is in the right position, but displacement is not in the right place, right? Why? Because let's say you are at point A and you want to go to point B. Basically, this is like 5 steps, and then you want to go backwards 5 steps, right? So your distance, which is actually a scalar quantity, distance is 10 steps, right? It's the total of basically distance, or basically the steps you have traveled, and your displacement is basically going to be 0 steps, right? Basically this tells you that displacement is a vector quantity because it matters, right? The direction matters, right? The direction matters, right? That's why you went forward 5 steps, which is a positive 5 steps, and then you went backwards, right? So it's a negative 5 steps, right? So basically this equals to 0 steps, right? So that's why in displacement direction matters, and yeah, so that's why it is in the wrong position. So option number B is incorrect. Let's check the other options as well, right? Option is right. Option number C says that time as scalar and mass as vector quantity. The only problem is that mass is in the wrong position. Time is in the right position, right? Mass basically is basically this ball has it has a mass of 5 kg, right? Now whether you move it towards the right side, left side, or anywhere else, the mass will not change. So basically, let's say the mass of this ball, whether it is on earth, in space, or whatever planet it is in, right, it won't change. The mass value is not gonna change, right? So basically it is a scalar quantity, right? Has no effect of direction, right? So that's why our option number C is incorrect, right? So let's check option number D, right? Option number D says velocity as scalar and force as vector. Now you know that basically velocity is in the wrong position. Why? Because velocity has the formula of displacement over time, right? What is displacement? Displacement is a vector quantity. So because of this, velocity is also going to be a vector quantity, right? So your final answer becomes A, right?